Section 3C Special Cases. So special cases are referring to whether you have more than one variable, which we haven't had so far, or you have something that you can factor out, and after one step you're not done yet, maybe. So the first one we're going to look at is what's called a difference of two squares. Now, this right here qualifies as a difference of two squares because difference means subtraction, and I can root a squared and I can root 4b squared. In the past, you've done something very similar to this. If I gave you a squared minus 16, it factored down to a plus 4, a minus 4. This is just an example where we had one letter and then a constant at the end. Now notice that when we factor a difference of two squares, we take the root of 16, we got 4 for each piece. We took the root of a squared, got a for each piece, and they have to have different signs. Now we know this is right because if I FOILed or took first times first, I get a squared. Last times last, I get 16. Negative 16 in this case, so that works. So this one's no different. We're going to factor this one. It is a difference of two squares, so I can go right to the factored form. The root of a squared goes first in each one, which is a and a. The root of 4b squared goes second, and the root of 4 is 2, and the root of b squared is b, so I have a 2b, and you have to have different signs. So plus and a minus, does not matter which order you have that. And this is considered factored. So a special case factoring. When you go to 26, you look at this term, you look at it and you see, yes, we have x squared, a y squared. It may look complicated, but the process is still relatively simple. Now I would recommend right away to look at all three terms to make this more simple. What do they have in common? Well, they are all divisible by 3. So I can make my life a lot easier if I factored out a 3. Oops, factor out a 3. And that would give you 8 plus, and then 48 divided by 3 is 16, and y squared. Now, I'm going to go to the side here, and I'm going to make my life even easier. And I'm going to write this problem without the y's. And I'm going to factor that. And I'm going to show you why when we get finished. So if we follow the same steps here, I need two numbers that are a product of 1 and 16. So 16, a sum of positive 8. Factors of 16 are 1 times 16, 2 times 8, 3 times 6, 4 times 4. Which pair adds up to 8? 4 and 4. So I'm going to rewrite this as x squared plus 4x plus 4x plus 16. Whoops, that should be blue here. So the middle two replace the 8x, which gives us, when I factor by grouping, these two have an x in common. I have an x plus 4. These two have a 4 in common. So plus 4 is taken out. We get x plus 4, which is good news for us because we want the same thing in the parentheses. So you factor out an x plus 4, and it's times what's left, which is x plus 4. Now remember, we took something out right away, and that's the 3, and that goes there. And the other part is we have y's in there, and they go on the end, right here and there in each one. And that's how you can put the y's back in. So this is the official answer. The 3 because we factored it out, the y's because we took them away, we got to put them back in. But sometimes it's easier to factor something with just one variable and not two. And that's the answer.